I'm going to stare right at the camera and click Start Streaming. And in theory, OBS is now sending to YouTube. I'm going to wait for the little YouTube page to come up and say, hey, look, I'm getting data. There we are. Okay. Hello, YouTube. Because live streaming is hard and they don't give us the URL until we've actually started the stream, let me interrupt what we're doing here a little bit, and I'm going to copy and paste the URL, share, there we are, that copy link, and I'm going to send it in chat to Paul so that Paul can share that link with people, and then I'm going to go up here, Mastodon, hey, Paul, who are you? P. Braun. Are you on Mastodon?
I am. Should be.
Are you? Is it your call sign? WD9.
God,
yep, there you are.
As I say, I'm on radio.io. So.
Oh, you're not on Mastodon.radio?
Nope. Yep. I'm sorry.
Yeah.
Brain cramp.
All right.
Mastodon.radio. Yep.
WD9GCO at Mastodon.radio. And I are doing another live stream talking about KiCAD. Live stream getting started with KiCAD. He's working or continuing work on his OHIS compliant user side adapter for his, can I type? David Clark headsets. Join us and join the Peanut Gallery.
Oh, you know what? What I'm going to do is also put that on 100 watts and a wire.
Ooh, snazzy. All right. I'm going to publish that. I'm going to bring up Discord. Wrong page. And we'll go to Ham Radio Workbench if we've got viewers. It looks like we've got one viewer. Thanks for hanging out with us while we go around to all the places and post links. Paul, have you joined our Discord yet?
I have.
WD9. Why can I not? Yeah, okay, I searched for Paul. Okay, anyway, there you are. And I are doing a live stream on YouTube.
Let's see, are we on the general or the halibut channel?
I'm in Halibut Electronics right now.
Okay, you do that, and I will do Ragchew.
No, don't put it in multiple channels on the same server, because everyone on one server can read all of those channels.
I'll let you do Mastodon.
Actually, you know what? You bring up a good point. I should probably not put it in. Actually, copy. Edit. Control-C. And then I'm going to delete this, and I am going to put it in Ragchew. I think you're right though. Ragchew is the better place for it. Okay. All right. Hey, how are y'all doing? We, in theory, have a viewer. Come say hello. Hello. Paul and I today are going to be working more on his KiCAD project to make a user-side adapter, an OHIS compliant user-side adapter for his Dave Clark headsets. We kind of got the first part of it done last time we did a live stream a week or two ago. But we have some other ideas that we want to do to improve it. You never order boards after your first day of
ever learning how to do a thing.
Yeah, or even after you've done it for years and you design a board and you get it laid out in the first day and you're like, okay, I'm done. Let's go order boards. Don't order the boards. Wait for a few days, sleep on it, think about it, and because invariably you're going to order boards and go, oh, darn it, I should have. Whatever. Keep
Feels
thinking.
like never do an OS update the first day it's released.
Well, yeah, kind of like that.
Yeah.
So, so anyway, yeah, we've got some other things that we want to do, and he's got that list of stuff up on the screen right there. One of the things that we're going to be doing is we're going to be adding artwork to the board, because every PC board needs at least a little bit of artwork on it. I always do my little fishies because halibut, and Paul has created a new logo for himself, his own stuff. He's always used the name Cygnus Productions, so he's got this logo based on the Cygnus constellation. I think it's rad. This one is done up to look like, the constellation diagram, but it also kind of looks like a schematic, so or a board layout. So I think that's pretty cool.
Now, ideally, we get the vias to line up with the holes on the...
You can do that.
Yep.
We can absolutely do that.
Yep.
So, hey, Jeff Glass, evening, y'all. Maybe in and out, but always glad to see some more KiCAD content. Thank you, Jeff. Glad to have you here. Okay. Okie dokie. To borrow the terminology from one of the actual play podcasts that I listen to, one of the guys, well, they're all from England, but one of them in particular says okie dokie a lot.
Yeah.
Okay, so we've got some changes we want to make in the schematic. So let's open up the schematic and look at all of our schematic-based changes first. Can you send me that text file so that I have it up on a different screen so I can look at what all the things are that we want to change?
Your
to-do list
thing? I can.
Tonight's libation is New Dry from the Far West Cider Company. This was given to me by my brother-in-law who lives up in the Bay Area, and this is apparently a local cider company. I think Richmond, California. Yeah. They're in the South Bay, but Richmond is, kind of local. Anyway, this is good stuff. I like it. It's my first time I've had one. My email address. Like it's hard to guess. Just copy the text.
Oh. Hi, my name is Paul. Again, I'm an idiot.
Hi, Paul.
Okay. Yeah, see, I was going to send you the whole document and stuff. This is easier. All right, then.
Oh, radio.
Back to the schematic. Here we go.
There it is. My laptop is buried under a bunch of stuff. Okay. So I'm going to hold off on replacing the RJ45 with the correct one because that's going to be pretty boring. Let's do some of the interesting stuff first. The first one on the list is add the trimpot. So what we are doing here is we are adding a voltage divider to the analog output of the amplifier. But there's also, so like analog is going from the microphone toward the radio, but DC is coming from the radio toward the amplifier on the exact same wire. So we need to be careful on how we do this. We want to have we want the voltage divider to affect the AC, but not the DC. And so what we're going to do is we are going to add a series capacitor to that potentiometer.
Okay.
And what that'll do is that series capacitor will make sure no DC... it's actually going to be on the other side because it's on the output of the amplifier.
It's going to be like this one.
Like that one. Yeah. But go connect to Mike goes out and then down to ground with it's going to be the series capacitor and potentiometer to ground.
Okay, so I need to, if I want to copy this, okay, I can just highlight it.
So, yes, however, that's not the capacitor we want to do because we need like a 47 microfarad or a 100 microfarad. We need a big capacitor.
Okay.
And that one there is a non-polarized, which means you'll be using it with like a ceramic capacitor or something like that, 1 microfarad.
Mm-hmm.
The big ones are going to be probably an aluminum electrolytic.
Okay.
And that's a different component. So why don't you zoom in a little bit so it's easier to see on the stream? And I'm going to make sure to keep my YouTube chat up on my screen so I can see what's going on. Okay. Cool. Go up to your drop components, or the add a component. Do you remember how to do that?
I got to think here for a minute.
Right, other side.
See, it's over on the other side.
Yep.
Is it that one?
Yes. All right. So, yep, it's going to be in capacitor. Oh, nope, I lied. Because we are on the schematic. It's in devices. No, you had it right. No, bringing that up. It's going to be in the category called devices.
Oh, God. Okay.
Yeah, or device, singular.
Here we go.
And there is a C. I'll go down to the bottom of the C's. No, the C underscore. There's like C underscore small for a small capacitor. That's what we were using before. This time we're going to use C polarized small. Yep.
Okay.
Just like that. So drop that down on the board. You want to make it so that the top of the capacitor is in line with that green wire.
So I'm not going to put it in line with. I'm going to rotate it, right?
No.
Oh.
No. So this is going to be a potentiometer to ground. So the amplifier itself has an impedance, and so you can view the amplifier itself's impedance as the top of a voltage divider, and then we're going to be putting a second impedance to ground. And that, between the impedance of the amplifier and the impedance that we're putting to ground, that's going to make a voltage divider. And the output voltage at this point will be based on the ratio of these two resistances.
Okay.
Okay.
So like this?
Yes, just like that. Go ahead and change the value of that to 100 microfarads.
Let's see. And to remind me,
V
V
for value.
Well, what did you say it was?
Like 100 microfarads. It's just bloody huge. Okay. And then we need to drop a potentiometer on the schematic.
Is it under that or variable resistor?
I don't know. So I always search for a potentiometer, and usually I find it. You can just go up to the top where the filter is, and just type pot. It'll show up. Oh, R underscore potentiometer. There you go.
This one here, trim, or this one.
So I
select. Trimmer might be one of those multi-turn ones.
Yeah, I don't know that it matters in the schematic. Go to trim. Just click it once so we can see the preview. 1, 2, 3. Yeah, I think it's ultimately it's not going to matter. It's just what is the.
It looks like they have the same.
Yeah, I usually do small or our potentiometer small. There you go, because that'll make it the same size as the other resistors. Okay, and below it, because we're going to bring it to ground. Yep. Ugh, that's annoying. M to move those. Oh yeah, set the value 1K. Because ultimately what you're going to be looking for is a value around a few hundred. And because I think the effective impedance of the amplifier is dominated by that 470, I think, if I'm remembering how this works correctly.
Okay.
The impedance of that amplifier is dominated by that 470 plus whatever the dynamic impedance of the transistor ends up being. Hand-wavy math for an effective voltage divider there, you need a impedance here in like 100, 200, 300, somewhere around there. And that's why the capacitor has to be so large, because the capacitor, the frequency where that capacitor divides between DC and AC, right? It's blocking DC and it's passing AC, but where that cutoff is between DC, which is 0 hertz, and
Yeah.
AC, which is higher than the cutoff. Where is that cutoff? That cutoff frequency is defined by the value of the capacitor and the resistance to ground.
Okay. Yep.
Right? And so if we need like a 100 ohm resistor there, then we need to have a large enough capacitor that it will still only pass audio frequencies. But, well, the problem is that if the resistance gets too small, the cutoff frequency will start moving up in frequency. And so it will be voltage dividing the high frequencies, but the low frequency audio will not get as much of a voltage divide. And so you'll end up with lots of bass going out, but the high frequencies will start rolling off. And that's not what we want. We want to attenuate all the frequencies as evenly as possible. And so to do that, you start out with a bloody huge capacitor.
All right.
Let me do some quick math to do that because I have a calculator here that does this. 100 ohms, enter 100 exponent minus micro is 6. And then I go to my functions, 1 over 2 pi r, C. Okay, so if you've got a 100 ohm resistor there with that 100 microfarad, that'll roll off at 16 hertz. So, quote unquote, above 16 hertz is AC and below 16 hertz is DC. It's not quite that sharp, but 16 hertz is the 3 dB point.
Okay.
So if you're down at 50 ohms on that resistor, then you're still rolling off above 32 hertz, right? So anyway, that's a reasonable value for what we're doing here.
Okay. Now you said to move them out a little bit.
Nope,
to give them
right there where they are. I was going to have you move the RV1 and the 1K over to the same side as the capacitance.
Oh, I see.
Yeah, just so that it's because when the value was super long, it kind of overlaid the transistor and it was annoying. But oh, you're getting fancy with the multiple selects. So you multiple select and then you hit M to move them.
Yeah, and then I accidentally clicked, which got rid of the M.
Okay.
Except I need to leave a little breathing room because there's going to be something connected to the slider, right?
The sweeper is going to connect to ground. Yes. So both pin 2 and pin 3 are going to connect to ground. Right. I need to step away really quickly. I will be right back. Keep working with that and then tie that to ground. And
so
then
both of these. Okay.
Yeah, and then Mike goes out connects back to the wire where it was before.
Okay.
I'll be right back.
Yep. And by the way, if you're asking questions in the chat, I can't see those. So when Mark gets back, he'll comment. And now I've got to remember. So that's Earth. Oh, power. Ground. All right.
Maybe a big bowl of ramen and broth right before starting a live stream wasn't such a good idea.
Yeah.
I suspect there may be one or two more of those coming up soon. Anyway, all right. So we've got. So that is going to be your trim pot. Now let's see here. As you have that turned all the way down, I think pin 1 is fully counterclockwise. And fully counterclockwise, so that's going to bring your sweeper all the way up, and that is going to turn your audio all the way to 0. That's correct. Okay, so yes, we have that wired up correctly.
All right.
And then when you bring your sweeper all the way clockwise, that's going to effectively move pin 2 down to pin 3, and so you'll have the most impedance there.
And right, because there's nothing dividing the impedance.
Well, but remember that the voltage divider is between whatever value RV1 is set to plus the impedance of the amplifier.
Right.
And I'm pointing at things with my cursor, which the stream can see, but I keep forgetting you can't. So sorry about that.
Okay, that's fine.
Yeah, okay, so cool. So we've added the trim pot. Add some test points to make it easier to measure things on your board if needed. All right, so let's do some test points.
Okay.
In here, okay, so test points are components. So go up to the add component again. Let me move my cursor out of the way so we're not confusing people. And search for test point.
Oh, wait, that's a symbol.
Nope, symbol is correct.
Oh, that's
go in there.
Okay.
And in the search field up at the top.
Oh, I still had a thing in the search field.
Yeah.
Test point.
Test point. Yep, yeah, that's fine. Now, I would put one on the node that is the wire that's connected to pin 2 of your transistor. No, of the transistor.
Oh, the transistor.
Yeah. I would move it over to the left. Anywhere on that wire will be fine. That's visually a little bit cleaner. Yeah. And change the value of that. So V, I don't know, amplifier base, amp base. Yeah, this value here only matters to us when we go lay out the schematic or the PC board. And then probably, I mean, Mike goes out is the same pin as what's on the header. So yeah, go ahead and throw a test point on there too. Might as well. Yeah, don't put it right on top of the junction. Put it somewhere in the middle of the wire. Yeah. Mike goes out.
Yep.
Okay.
All right.
I don't know. Do you want any other test points? Do you ever want to test any of the other?
I think that's. I don't, because I'm not. I mean, if you could throw 100 test points in there, I wouldn't necessarily know what
to do with them. Yeah. Okay. All right. So that's good enough. All right. So next up, split the grounds on the board, but add jumpers to allow combining at build time, and then expand the 4-pin header into a 6-pin with separate grounds. Okay. So what I think we want to do is the headset connector over on the left, the 4-pin.
Mm-hmm.
Let's change that to either a single 6-pin or 3 2-pins.
Okay.
Okay. And then you get, it's just a build style as to which one of those you go with. But we're going to put PTT and power ground on one of them. We're going to do mic goes into and mic ground.
Now don't. Yeah, right.
Yeah. Oh, that's right, because we combined all of the grounds over at the OHIS connector side. So we want to...
because of the Dave Clark wiring. But yeah, we wanted to make this more universal to use it with other things if we need be.
Correct. All right, so let's do that. Let's split the grounds first.
Okay.
Okay, so on the mic amp itself, where you've got the ground flag, replace that ground flag with a mic ground.
This one?
Yes. Just delete it. We're not going to be using ground as a separate flag. So the labels, the hierarchical flags, I think is what it's called. The like the mic goes into and mic goes out. Yes, that. What are these? Global label properties. Okay. So label it, just say mic ground. And rotate R for rotate. Yep. And then we're going to do the same thing. Replace the ground flag with the mic ground label on pin 3 of the OHIS connector. And you can figure that out from the OHIS documentation, or if you're like me and you just remember it, then I just remember it. So mic goes out and mic ground are on pin 3. Okay. While we're here, delete the ground that's on pin 5 on the OHIS connector and replace that with a... Oh, nope, the whole thing. There you go. And replace that with a global label called headphone ground. There you go. Okay. And then we'll go ahead and use the ground flag to mean power ground. We can continue to do that. That's fine. So we've split our grounds. Now we need to make the headers over on the left-hand side. So delete that 4-pin headset connector because we are going to use multiple separate connectors.
All right.
Let's drop another component on the board. And you can search for connector, or I can tell you, scroll all the way up. Yeah, I'm sorry, maybe not up. No, con_01_02 is what it's going to be. Yeah.
Socket?
Or pin, whichever. I usually go with pins, but I don't think it doesn't. Oh, wait, no. Where's generic? Did they get rid of the generics in 7? What the what? Oh.
Here, connector generic.
Oh, bloody hell. Okay, yeah.
Well, there's also connector generic mounting pin.
Yeah, we're not doing a mounting pin.
So is it 01 by 02?
Yes. So that's just going to be a 1x2, jumper header.
So this one.
Yes. Yes, that's what I wanted to see. Okay. If it were me, I would hit X to swap it in the X direction. There we go. Just place it there and change the value of that. We'll call that one the mic header. And then put a copy of mic ground on pin 2 and mic goes into on pin 1. Yeah, just move that one up. There you go.
And
not that ground. You want mic ground.
Mic ground is a thing now.
Correct. It's a global label. Where did I get the name flag?
So if I right now, am I copying just the text?
It's a good question.
That's the only thing. Let's find out, shall we?
Yeah, let's find out.
Copy. Paste. Up does the whole thing.
Woohoo! Perfect. Do the same thing, and we'll call it a PTT header. And hey, look, you've got ground and PTT right there.
Oh, hang on.
So apparently we got 3 viewers right now. If you are comfortable doing so, sound off. Who do we got in the chat room right now? But only if you're comfortable doing so. We'd love to know who you are. All right, and then
feel free to ask questions. I'm up here in public learning how to do stuff and looking dumb, so don't worry about asking questions.
You're not looking dumb. You're actually doing great.
Okay.
Now drop a con01_03. Let's put the headphone header down there. 3.
What? Oh.
You can hit escape and it'll cancel the current one. Yeah.
Connector generic.
Yep.
01/3.
Correct.
Mm-hmm.
I'll put that on pin 1. Left on pin 1, right on pin 2, and headphone ground on pin 3.
I thought...
Is value not letting you change it?
Value is not letting me change.
Okay, then just go with an E, then edit. Yeah.
Oh, I double click on the text.
Oh, that works too.
And it opens it up. Alrighty.
All right. Grab that whole block, select it, and drag it down one. No. Just the headphone, because it is the J4 is impeding on the one right above it.
Is there a drag select?
Yes, there is.
Oh, that's right. Left, right does different things.
Yes. There you go.
And we can move this one down a little bit too, just to give it a little space.
Yep.
And it looks prettier. All right.
Okay. So those are going to be the pins that you are going to wire your connector to. But you also need a way to tie your grounds together.
Mm-hmm.
Now, you can either do it by wiring multiple wires to the tabs on your physical connector, your panel mount connector, or we can put some jumpers on the board itself to be able to short them together. Do you have a preference on which way to go with that?
Okay, so the panel mount connector has 4 pins. Tip, ring, sleeve.
Mm-hmm.
So...
if I remember correctly, tip is ground.
Yes, it's backwards.
Yeah.
And then the first ring is push to talk, or in this case, nothing. And then headphone, mic. So what you're saying is coming off of the ground lug on the connector, just make 3 little pigtails.
Correct.
That tie them all together.
So that is an option.
That's decent.
Okay. Then we don't have...
otherwise, this way we leave it. I don't have to do anything funky if I make one with this board for like my Heil, which has separate grounds. Okay.
Correct.
Let's do it that way.
Okay. All right. Speaking of one for your Heil,
yes,
my other recommendation is to drop a couple of 3.5 millimeter sockets on this board as well.
Yeah.
Actually, 3.5 millimeters, because we are talking about doing PTT, mic, and headphone.
Mm-hmm.
Now, do you want 3.5 millimeter for the PTT, or do you want to try and squeeze a 1/4 inch on there somewhere?
I don't think there's going to be room.
Yeah, I don't think so either. That's why I did with 3.
Because I mean, it's this size, and so roughly the RJ45 would take up about that much space,
close to it,
and that's not enough for a 1/4 inch. So.
Yeah. Okay, so then let's drop another component.
Alrighty.
Now here you're going to search for TRS.
Just under connector?
No, the search bar, the filter bar. There you go, audio jack. So you need to choose which component. Damn it, I never think about this because I've settled on one particular outline that I always use. Oh, curses. You know what? Stick with this for now. We might swap this out with a different outline later.
Okay.
But just go with the audio jack 3. Oh, yeah. Let's go ahead and select the footprint now while we're at it. Let's go look at some of these footprints and see what they... does it give you a preview when you select one? Oh, there it does. I'm assuming you're not going to want surface mount because
That's
you're
correct.
hand assembling these.
Yep.
So I would look for one that has a through hole. And I don't know...
SMT.
Oh, yeah. Is SMT part of it? Oh, that one is, yeah.
Yeah. So this one is not SMT.
Let's take a look at that one.
Horizontal.
Okay.
It's board mount, though, but it's through hole.
It's through hole, yeah. Now, okay, so that is a very common connector, although the switched version of that is very common. The problem with those, they can be very rugged. The problem is that they take up a lot of board real estate side to side. And so if you want, because you have limited width and you want to be able to put 3 of these on a board, you may want to choose a different one that is a narrower outline on the board.
Or not necessarily use board-mounted ones.
Oh, yep, you could do that too. But if you're going to be making these boards for other people, let's give them the option of doing board-mounted.
Okay.
Like, we can put the outline on the board, and if it doesn't get used, then it doesn't get used. We
just solder wires to it.
Don't even have to do that because you've already got the pin headers on it, right? So there are going to be 2 connectors tied to these wires. There's going to be the pin header connector and the socket, and you get to choose which of those 2 to use.
All right. There's a narrow one.
Yeah, so I have used... Okay, no, hold on. Go to audiojack3_switch TR, I think is the one.
Oh, just
Switch TR, yeah, I think that's the one. Now choose the footprint on that one again. And look for that same...
Well, there's horizontal and horizontal circular holes.
Not the circular. Yeah. So those are super common and cheap on eBay.
Cheap is good.
At least they were when I ebay.com. It's a CUI. Here, let me do 3.5 millimeter socket. I think those are the ones that I was using. Shoot. You know what? Maybe I can't find those anymore. At least not right now. So that's a 5-pin. Is there... phooey. Let me show you what I'm looking at. Oh, shoot. I can show the listeners what I'm looking at. That doesn't help you, though, does it? What is going on? What? Paul, can you hear me?
I can.
There we go. Okay. Weird things were happening. Phooey. Why is my browser doing weird things? My browser is doing weird things. Oh, there we are. There's some good ones. Yep. I think these are the ones that we're looking at. Okay. I'm going to paste a link and have you bring it up in your browser. Try that.
Mm-hmm. And they come in colors.
They do.
All right.
So on look at the size drop down. Oh, 22 New Century. I bought from them before. The down. There's a yeah, right there. So it's just a general option that you can set. I would only 6 pieces. How much is it at 6 pieces? Yeah, I mean that's $1 a piece. But go to the blue 30. Now it's $10 for 30 of them.
And blue is perfectly good.
Yeah, blue is perfectly good. So this is the kind of thing that I usually just like, okay, give me 100 of them. I just buy, once I find a part that does what I need it to do, it's like, just give me 100 of them. I'll keep them in stock on my parts bins, and I use that component for everything from here on out, kind of thing. So these are reasonably good sockets that I've used. It's eBay, so it's always going to be less than quality, but they're inexpensive and they get the job done. So go back to KiCAD. It is that outline. That is the outline. So this is going to be over on the left, because these are the same connections as your pin headers. So make one of these a PTT header, make another one for a mic, and make another one for a headphone. Or PTT socket, not header.
Except that I want... Well, I don't know. Okay. For me, I would like to have the push to talk on the same end plate as the OHIS, the OHIS connector. Because sitting on clip to my belt, I want the headset coming in the back, out of the way, and then if I use the PTT on a pendant, it could lay across my lap that way unless I picked it up. So that's why I was thinking that one would be like, I'm pointing on my screen, like you can see that.
I can't see where you're pointing on the screen, but I can see your hands.
Yeah. So push to talk. So let's do that. So push to talk would be here, and then is it X or rotate? No, it'd be X, right? You can't flip these.
Yeah, you can flip that across the X. Yeah, you can do that.
So I would put that there, but now I would put 2 more over here
for headphone and mic.
Yep. Oh, hang on, I need to value. Headphone, and one more. Okay.
Now copy your global flags into the right places.
All right, so that's because this is a 3-pin, so we want it between, let's see, no, this is going to be tip.
PTT is tip and ground is sleeve, correct?
This is going to be it.
Are you not a keyboard copy and paster?
Yeah, I would. Control C, Control V works here too.
Yeah.
Okay, awesome.
Oh yeah, absolutely. Yeah.
All right, so we got ground and push to talk. So now we also need to do that would be the tip, which is down here. And that goes here. Headphone ground. Oops. Goes here.
Yep.
Headphone right. Goes. Is it? Yeah, let's see. So it would be right, left. Right would be the tip, right?
No, right is ring.
Right is ring?
Yeah.
Okay.
The tip is left. Okay. That looks good. I'm going to make another suggestion that's not on our list.
Okay.
Unless going with the anyway, go drop a component and look for search for button. I think it's going to be in switch. Switch push, SW push. Yep. And put it over. Which side of the board would you want to have a push button PTT on?
For me, neither. Because I've got.
Yep.
Okay, it's black and not showing up well, but this is going to, as the box is hanging on my belt horizontally, this is going to be drilled into the top side.
Okay, and so that's going to go into the header
on the box. It's just me going to a header.
In the header. Okay, got it. We can remove it later if we don't have enough width for it. Go ahead and put it on the other side of the OHIS connector. And just do PTT and ground on either side.
Oh, put the flags there?
Yeah.
Okay.
Okay. 4-pin header to a 6-pin header with separate grounds. Okay, a second dedicated PTT ground header for a button inside the box with the JHS socket. Going with
we've kind of worked around that.
Yep, that's what the PTT header is going to be. That.
Yep.
Add 3.5 millimeter sockets on the unused end of the board that we can leave unpopulated for your DCs, but would allow others to populate for more common 3.5 and 1/4-inch sockets.
Yep.
So current Heil headsets come with 3.5 millimeter connectors molded onto the cable and then a screw-on adapter to bring it up to a 1/4-inch.
Yeah, I was a bit confused on that. Then I went out and looked at mine, and mine's 3.5s on both.
Okay, yeah, same with mine.
Yeah, it's when you've got one of their radio adapters, the push to talk line coming out is 1/4 because all of their foot pedals are 1/4.
Yeah,
you can always use adapters to make that work.
Yeah, plugging a 1/4-inch male into an adapter into a 3.5 millimeter socket is something that I've tried to avoid, but we don't have space for a 1/4-inch socket on these boards. So,
correct.
Like, there's only so much we can do.
Yep.
All right. Add 3 millimeter on the OHIS side to RJ45 directional PTT pendant. You've already done that. Add the artwork to your board because every board needs a bit of artwork. I agree. Draw the end plate circuit board. Design boards for radio not pro and end plates with RJ40. Yeah, DC. Okay, we're not doing that yet. So
that's another It's just note to myself.
Yep. Totally legit.
Yeah, because that's what I'm calling these. I'm calling them the radio not pro.
Not pro.
And the user not pro.
Yeah, we can't call them the radio amateur because that has a different term, different meaning.
Yep.
All right, go up to the PTT button and hit E. That's the global label. Go to the button and hit E. So we're going to edit that. Nope, no, still the global label because you have it selected. Hit escape.
Yep.
All right, go to hover over footprint. Or click in the footprint box. Yeah. Now, see the 3 little books over there? That means view the library. Yep, exactly. Button switch THD. Okay. Now, I'm going to have you scroll through here. Well, not scroll because I know they're not the dips. It's going to be near the bottom probably. Push 6 millimeter, and we're going to be looking for one that is a right angle. Yeah, just scroll down. Or not scroll down, but yeah, do what you're doing.
That's all of the 6.
Yeah, no, keep angled. There we go. Those are the ones. Yeah, find one that's got, I mean, this is just a difference of artwork. Find one that's got a longer button on it. Yeah, like one of those. Go the next one down. Oh, that works. That's fine. It's good enough. Yeah. It just needs to be long enough to poke through the panel.
Okay.
All right, cool. That's good. Click OK. Now, have we set outlines for everything? I'm pretty sure we have not for the pin headers. Rather than, you can either edit these one by one, or there's another tool up at the top, kind of the 1, 2, 3, 4, 5th button from the right, where you see like from the right. The other right.
That's the other left?
Yeah. That one right there, where it's like a chip and a schematic outline. And what it does is it allows you to map, these are the things on the schematic, what footprints should they use? These are the components on the schematic, what footprints should they use? So like we have not selected a footprint for C2, which is the 100 microfarad capacitor. So do that, and over on the left, we're going to select the library first. So capacitor, it's not a tantalum.
Through hole.
Yeah, through hole. So you're probably going to want a CP_axial. So capacitor polarized _axial, not axial, radial.
Radial, yep.
Yeah, radial. So just select one. I want to see if it does a preview automatically. It doesn't. All right, so where is it? The upper left-hand corner, the chip with the microphone, or the magnifying glass. That'll bring up a preview. There you go. It will probably have a pin spacing of 2.5 millimeters. So find something with 2.5 millimeter where in the text is P 2.5.
Yep, there.
Yeah, for what we're talking about, this is all going to be low voltage. Maybe 5 millimeter. What's the next one with the 2.5? 6.3 millimeter diameter?
6.3.
Yeah. Just give yourself a little bit of space. I don't know how big the capacitors are going to be that you're... Did you actually select it?
I think I did. I apparently got out of the thing.
Yeah, no, it's over right. 2 more, 3 more. There you go. That one. Nope, you didn't.
Oh, look. I didn't.
So
Shame on me.
Yeah, don't click OK, because that closes this entire window. You want to... Well, select the library first. Yeah. I think we said D 6.3, P 2.5.
D10. D 2.5, D 6.3. Okay.
Yeah. So double click that. And then that sets that in the mapping.
Okay, now the mic header.
Okay, so these are the pin headers. So I think there's actually a library called pin header. Nope.
Or there isn't.
There just isn't. Scroll up. Oh, it's connector something something. There it is.
Pin header.
Connector pin header 2.54 millimeter. That's the one you want.
All right.
And again, we're going to look for a 1x2. And you may want to bring up the preview as well, just so you can see what it is that you're going to drop down. It's the upper left of that window.
That's what I was looking for, where it went.
Yep.
That's 2.54.
Yeah, what's the one right above it? Oh, right angle. Okay.
Oh, yeah.
Yeah. So, yeah, vertical, that's probably what you want. So, double-click that. Same thing with PTT.
Same thing.
Not for headphone, because we're going to do a 3-pin for headphone.
Okay.
So, for PTT...
it was 2.54. Nope, that looks different.
Yeah, that's the surface mount one. So, go to the next one above it.
Yeah.
There you go.
That's the same description as the one above it.
Yep.
Okay, so now headphones.
1, 2, 3, 4. Why are there 4? Okay, that's fine. So headphone is going to be a 1x3.
1x3, yeah. So.
Nope, you scrolled past it already.
Oh, I lost
it's going to be right below 1.2.
That's surface mount.
Yep. So go up to the, yeah. There you go. All right. So, why did this one not get set from, okay. So, because you dropped a new component rather than copying the previous component. So it didn't copy the fact that you had already set the outline or the footprint on the first one that you dropped down. So let's just select that same one. So go find the connector_audio library.
Okay, and then 3.5. That's surface mount. Nope.
It's going to be CUI SJ1. I can't read it. The text is awfully small here.
Okay, well, I've got SJ1 3533.
MG _ horizontal.
Yeah, except this has only got 3 pins on it, so that can't be right.
Scroll, yeah, go to the next one down.
There's 4. 3535 NG.
Yeah. Okay. Make that the assign footprints window, make it wider, because there's more text to the right of this that we can't see. Yeah. And then drag that bar, over to the left. There you go.
Oh, horizontal circular holes.
Yeah, we do not want the circular holes.
Okay.
Okay, so that looks like the right one.
So this one.
That one, yeah.
Okay.
And then select that one for Mike as well. Yeah. All right, now we're down to the trim pot. All right, so you said you already have a trim pot?
Well, except that I was at the local electronics store and I was trying to figure out what value to get, and I'm Googling values for volume trimmers, and I came up with something which is completely too high. So let's now that you've done actual math.
Did you get like a 250K or something?
It's like 50K.
50K, okay.
Yeah.
Yeah, it depends on where in the signal chain you're doing the actual volume setting as to what value you get. For guitars and whatnot, instruments, 250K and 500K are very common values. But and then for line level, 10K and 50K are pretty common. But in this case, we want a 1K. So that's going to be potentiometer, probably through hole. And find one of these in here that looks like the kind of thing that you can use.
Okay, so that's, well, horizontal, so it doesn't matter because, I mean, we're going to adjust the value before we button it all up.
Yeah, but you still want a vertical one because then if it's horizontal, you can't line them all up, right? They all have to be accessible.
Yeah.
Rather than clicking, you can also, once your active cursor is in the right-hand column, you can just use the arrow keys to go up and down, by the way.
So that looks... And then that one's got, so that one could be adjusted from the back of the board. Is that what the hole's for?
Yes. That's assuming you have one of the potentiometers where the adjustment is on the board side of the component, which I've seen before, but that's probably not very common.
So this would probably be, let's see, let's look at that one. Here's a vertical.
Yeah. Those are full-size pots.
Yep, don't want that.
Probably not what you want.
Okay, so this...
That's a full-size pot.
All right. So then we're going to want to go with something more like...
Scroll down. There's more down at the bottom. Go below the Alps RK097s. Those are all full size. All the Alps RKs are big ones. Okay, so Born is the the little multi-turn ones. I don't know if you want to do that.
No.
Okay.
Alps are sweet though.
They are.
They're also really expensive.
The RK27s are, yeah.
All right.
The RKO97s aren't as bad. They're a lot smaller, but they're still pretty good.
So these are like ones where you've got a shaft that would poke through a front panel and have a knob on it.
Yeah, that's not what you want. So I think you're looking at, this is one of those times where you kind of have to pick the component first and then pick the outline for the component, because there isn't really a standard for these sort of things.
Yeah.
I typically either use the Burns multi-turn trim pots.
Okay.
Or now that I'm doing things surface mount with JLC PCB, there's a Burns potentiometer that they have available that they can assemble, and I use that. Now, I'm not saying that you should be using those. I'm just saying that that's what I've used historically.
Right.
It certainly would give you awfully darn precise control of your mic level.
Yeah, 13 turns, whatever.
Yeah.
I at this point, I don't. This one says hand soldering.
That just means it's got bigger pads.
Yeah.
Yeah. All right, so let's go eBay. Nope, I was already on eBay. That's the one that I'm going to keep. That's one to get. Okay, so 1K pot potentiometer. All right, here's a good option. All right, so I just sent you a chat. Actually, I'm wondering whether 500 ohm might be a better. Wait, what? Located in San Luis Obispo, California?
Who's you can walk over there.
Yes. Who's this seller?
Mr. Circuit 23. All right, so that footprint is RMO65. Is that the?
Yes. Search for it and let's find out.
Okay. RM0. RM063.
What does that look like? So these are vertical trim pots, and the other one was a horizontal. So no, but it does look like the same construction style. Just, vertical versus horizontal.
Although, does that?
I mean, you're not going to use that exact outline there because that's wrong. But the question is whether there's another one that's very similar to it. So,
okay.
Yeah, go ahead and minimize your browser.
So it's very much a equilateral triangle. All right, so then we need to go back to.
Oh, right there.
Oh, 65. Duh. Hey, look. That looks like the one.
It does look like the one.
All
right, let's do that. And then test points. Okay. So there is a category, there's a library over on the left for test points. There you go. Because you're filtering on a text, yeah. There you go. I generally don't actually put any wires in my test points. I just have the pads on the board, and as long as the hole's big enough that it will kind of capture the meter test lead.
Yeah,
right.
I'm good with that too.
Yeah. So test point underscore pad, D 1.5 or D 2.0. No, not the through hole. Oh. Where's THT pad? THT pad. Those are all surface mount. Go down to THT pad.
Oh.
Yeah.
Okay.
There you go.
1.5.
With a drill of 0.7.
This is a drill of
1.0. Yeah. That's probably a good one right there. 2 millimeters. That's going to be a little bit, actually, that's pretty large. But it'll still get the job done. Yeah. 2 millimeter with a 1 millimeter drill. You have them set to different values. Yeah.
There we go.
There you go.
Okay.
All right. So save your board. We're not quite done yet, but I need to take another bio break.
All right.
I did mention a big pot of broth, right, for dinner?
You did.
I'll be right back.
Okay. I'm not sure, because I can't see how many are watching. In case you didn't see last week's, I'm doing a homebrewed version of the OHIS interface, primarily because my preferred headset, which is this Motorola branded David Clark built military surplus one, because it sounds great. It's rugged as heck, and it's comfortable as all get out. I can wear this for 3 or 4 hours with no pain, but it's got a weird, funky 4-conductor military plug on it, and it's also wired with a common ground for the microphone and the headphones, and theoretically it's got push to talk button on the ear cup. I'm not using that. I replaced that with a double pull, double throw phase reverse switch for one of the ear cups, similar to what Heil uses for the phase reverse on their headphones. If you have never tried that, it sounds like it shouldn't work. The brain does weird things, and it works very well. So I pulled the push to talk switch and I wired that in place. So I'm not using the push to talk line on that socket, but I found the matching Nexus socket for that 4-pin 1/4-inch plug. And so I've decided to wire up my own adapter. So this is going to be for one of them for my portable POTA rig with a Yaesu FT857D. And then the other one I'm going to use here at home on the Kenwood TS590S. So, and instead of hardwiring it, I've been convinced to learn how to do a circuit board design, which is actually rather fun. He's back. He's got his headphones on, everybody. Stop talking about him.
Oh, well, I mean, really? Do you need to stop talking about it? About me? All right, so let's look at the list of stuff. Replace the RJ45 with the correct one. Add the trim pot, add some test points. Split the grounds on the board, add jumpers. We're not going to do the jumpers. Expand the 4-pin header to a 6-pin with separate grounds. Done that. Add a second dedicated PTT ground header for a button inside the box. Add 3.5 millimeter sockets on the unused side of the board. Add a 3.5 millimeter socket on the OHIS side next to the RJ45 for external PTT. Add the artwork to your board, because every board needs artwork. Draw the end plate circuit board hole. And design board for Radio Not Pro and end plates. Or the Radio Not Pro. Yeah, okay.
Yeah, and that's something I'm going to try
on your own
based on what I've learned here.
Nice, perfect.
And if it goes completely off the rails, then I'm going to contact Uncle Mark. But in the meantime, because it's the same size board and everything,
yeah,
and there's less stuff on that side for what I'm doing.
Okay.
So
perfect. Then the only thing left to do is to swap out that RJ45. And it's not even that component that it's not the schematic component, it's the footprint.
Right. You said you had a footprint for the specific.
Yeah, but that means I got to figure out how to export it.
Sorry.
Yeah, that's fine. I'm gonna. You may want to open up the live stream in a different tab somewhere on a different screen. I don't know how many screens you have, but I am going to do some things on my screen.
Okay, hang on. I have another Mac over here.
Okay. So, dear listeners, I have all of my custom outlines that I've made in a library called Library. And I have a whole bunch of them in here, but the one in particular, nope, those are RCA. Nope, that's the panel outline. Those are surface mounts. Nope. Because this is an old one that I laid out. And reverse. So it's this reverse is the critical part. So I sent him some of the RJ45s that I have. And let me make sure that these are... Did you ever get the ones that you ordered?
Yes, I did. And they are exactly the same as
They
yours.
are exactly the same. Okay. So...
Okay, I'm trying to find... Oh, here we go.
So pin 1 is there. And is that pin 1? That is pin 1. Okay. All right. So the problem is, and I don't know how well you can see this, but the stagger on those pins is opposite of what was a standard stagger for these for this kind of connector. I'm hearing myself in your coming through your audio.
Yeah, I just muted the other one.
Yeah. There we go, RJ45. So this is the standard RJ45. Let's see if I can find... Nope, that's a... Nope. There we go. And if I plug this in here... You've got to be joking me. Is that... Oh, no, but that's because that doesn't have a shield. So the pinout is actually very similar to that right there. But I need to find one that has the shield holes. So what I'm doing is I'm looking through the outlines that came with KiCAD 6. And I think I was actually using KiCAD 5 when I did this. And it did not have the outline for the connectors that I got from eBay. And yeah, now we're down here. Oh, that's awfully close. Damn it. That's it. Did I build this thing for no need?
Awesome. So it's a Ninigi GE.
I think so. See if you've got that in your...
So footprint is the thing here with this one, right?
I can't see what you're doing. Hold on for a second.
Okay, so the footprint assignment tool, is that where I'm going back to?
Yes.
Okay.
Damn it. I think that is. So all this time I've been using a custom outline when that right there, I think, is exactly the outline. I wonder if this was added in KiCAD 6 and I created my outline in KiCAD 5.
All right, so I'm looking on the left connector RJ.
That stagger is correct. And that is, in fact, pin 1.
Okay.
Yeah.
NINIGI.
Correct.
NIGGE.
Let me see your board. We'll do that. Can you bring up yours? You may have selected it and brought it up when it was too. Bah. Oh, that's not what you needed. Go back to the schematic and go to the mapping tool. Nope.
Map. Nope.
So close.
That one.
Nope. Two more to the right.
Three. That one.
Yeah, that one. There we go. And go to the OHIS connector and click the chip with the magnifying glass so we can get a preview.
Mm-hmm.
Yeah, darn it. All this time I've been using my own custom connector, and it's right there.
Well, think of that sense of accomplishment you have.
Right? Okay, select that part. I think you already have.
Already did.
All right. Then I think that's all the things we were going to do. So save this, and then let's go back over to the board program. Okay, so all that beautiful work you just did?
Yeah.
Yeah. Go up. So do you see where on the top bar there's a drop down that says F silkscreen? 2 buttons to the left of that?
Yeah. Does that mean something different now?
Nope.
Than front?
Nope. So that button right there, it says update the PCB with changes made to the schematic. So that's going to pull in everything we've done from the schematic. So hold on, let me read these checkboxes. Relink footprints to schematic symbol based on the reference designators. I think we do want to delete footprints with no symbols. Replace footprints with those specified in the schematic. Yes. I don't know about the relinking, whether that's needed or not. So go ahead and click. We don't have any errors or warnings, so go ahead and update. And all kinds of things. Hit close. There should be a bunch of new components. Oh, there they are.
Oh, yeah. And a whole new rat's nest.
Yep. So drop that there. Okay. First thing I would do is I would try and fix that RJ45. So grab the, unselect everything else. So hit escape. Yep, there you go. Usually you have to select it by the line, yeah. Rotate. Nope. Ignore the pins. Yeah, you're going to have to put it, okay, first off, you are currently grabbing it by one of the holes, and that what you want to grab it by the outline itself so that it gets it from the center, because we want to anchor it based on the center line. So okay, so you notice how your cursor is hovering over the hole there?
Yeah, but I didn't grab. I put my cursor over the line.
Okay, go more toward the center of the component, like over the J1, and hit M. There you go. Now it grabbed it from a center anchor.
Okay.
And scroll down a bit. I think I'm kind of trying to center it based on the mess that was left behind in the.
Okay.
That's too low.
That's close.
Yeah, I think that looks right. Didn't we drop a center line on this thing?
We did not. No.
Oh. Go to the user drawings layer over on the right-hand side. Yeah. So, yeah, that one. Yep. Okay. Then draw a line, not a trace. So there's a line draw tool. Yep. Where is the center line of the board? Okay. Hover your cursor over the top left corner of the board. Oh, zoom in. And it's not on a... Fuck.
It's not on a grid.
Yeah, because you're in inches.
We drew the board in metric.
Yeah, okay. Change the board back over to millimeters.
Okay, how do I do that?
Over on the left-hand side, There's in, mil, and millimeters on the left column, very left of the board. Down to, in millimeters. Okay, and then we're going to, in the drop downs on the top row, or the kind of the second from top row, change the grid, I think, to, I think we did 0.5 millimeter, 0.5 millimeter.
That's 0.508.
Because that's a round number in inches. Go down to where it transitions from round number in inches to round number in millimeters.
0.5.
Yeah.
Yep.
Yeah. Does that allow us to hover over the corner?
Yep.
Yeah.
It does.
Okay. Hit space. Your screen is not maximized. Oh, yeah, it is. Can you make your dock go away?
Yeah.
I don't know how to do that.
Mm-hmm.
Actually, what happens if you maximize the window? Is the KiCAD window maximized right now?
Let's see here, dock. Automatically hide and show the dock.
Okay. All right.
KiCAD is now full screen.
Okay. Because down at the bottom we have all of those X and Y coordinates. And I'm going to show you some neat tricks with those X and Y coordinates. So you got the mouse hovered over the left corner. So hover the mouse over the left corner. Nope. Yeah, don't select anything. Zoom in onto that corner. Yeah, I still don't think that's on the grid, but it'll be close.
I'm like in the center of that space.
Yeah.
Or do you want it like up here?
No, the center of the line. But I don't think you're actually, that's not actually, I guess it is center. Okay, hit space. And do you notice, look down on the bottom, do you see where it says DX and DY?
Mm-hmm.
So those are now 0. Right. If you zoom back out, then go to the opposite corner of the board. Like all the way opposite corner.
Oh, over here.
Yeah. And hover over that. Now your DX, DY show you the exact dimensions of the board. So whenever you hit space, that like rehomes your, delta metrics.
Okay, that says 85 by 46, which is right.
Okay, so the 46 is the short one, then 13 millimeters is where we want to draw a center line, just so that we know where that is. So go up 13 millimeters from where you're at now. So your DY will show 13 millimeters. Should be about halfway, or should be exactly halfway up the board. Right? Whoa. Did you say 46?
Yeah.
23. I can't do math. Not 13. 23.
And I'm not thinking.
Yeah. Okay. So that 23 millimeters is the halfway point of the board. So go to your line tool, your line draw tool. And we are already on the user drawings layer. So I would go, don't do it right on that line. Go out into space over to the right some. Out there somewhere. Make sure you're on 23. Are we really on 0.05 millimeters?
I think so.
Yeah, that's obscene.
Yeah, we are.
Yeah, change your grid to like 0.5 millimeter. We don't need that level. Nope. Hit escape. Up. Yeah.
0.5.
There you go. That'll make it snap a lot easier. Up one more click.
24, 23.
There you go. Yeah. Yep. And you're at 23. Go back over to where the end of that line is and double click. Sorry. Click once while you're hovered over it, and that will end it. There you go. And then do the same thing. It was 80.
That'd be 42 and a half.
So it was 85 millimeters?
Yeah.
Okay, so 42 and a half. Yep. You know what's going on. You understand it. There you go. So those are your center lines, and that's going to help you kind of locate where things are on the board. So now I would take that RJ45 and center it. And select it, but then hover over the center of the connector before you hit M. There you go. Yep, exactly like that. You can probably get it a little closer to the edge to the right. One more click. Okay, that's about as close as you would want to get it. And I think actually that's plenty of board because that's a big, thick pad there. So I would leave it right there.
Okay.
That'll give it the most opportunity to stick out through the panel, right? You don't want it inset in the panel. You would like it to actually stick out a little bit in the panel. Your panel is going to be 1.6 millimeters thick. So you can actually go in and measure 1.6 millimeters from the edge of that board. You can draw that on the screen and see where the panel is going to be on that connector.
Oh, okay. So it's 85, so that would be 86.6.
Well, I would just, or you could just go down to where they intersect now and hit space and move out to 1.6.
So go like right there.
Yep. Yeah, we're at 1.5. We're at a 0.5. Yeah, so right about there is where it would go. So, yeah, it'll stick out about one PC board's width. I think that's fine. Yeah.
Yeah. All right.
All right, now we got to go rerun some of those traces.
Yes, we do.
So I would just delete the traces that are there. Yeah, delete all of those traces, actually, because there's a lot of stuff we're going to be changing. Yep. Actually, those you can leave because that part didn't change. Control Z 2 more times. There you go. And then I would remove the one coming out of R2 going toward the RJ45. Yeah, that one. And then the one that goes through the pad. No, to the right.
Oh, this one.
Yep, that one right there. And then you've got a little whisker of one to the right of where you were at now. Just to the right of that's pin 7.
Oh, there it is.
Yep. Yeah. Okay, we've also got some vias that are in the way now.
We do.
Yeah, so get rid of those. And then you've got one underneath the blue drill at the top. Yep.
This one can stay, or is it?
I mean, yeah, that one's good where it is.
Okay.
Hit B, Bravo, and that refills all your zones. So we're going to be changing these zones before we're done here, but that just cleans up a bunch of the crap. Okay. So the next thing I would do is I would lay out the other things that are going to be on the edge of the board. So you're going to have one of those 3.5 millimeter sockets, the PTT one right there. And you're going to want to put it next to the RJ45. Now, this is another case where you want it to line up at the edge of the board. Yeah, somewhere around there.
And that should be enough space between the Ethernet plug and the 3.5 millimeter.
So there's only so much space you're going to have.
Oh, yeah. Now that I look here.
Yeah. Now remember
this right down there, that's the inside edge of the case.
Correct.
All right.
So I would give yourself a little bit of clearance, but not a lot. You want that as close to the edge of the case as you can get because you do want to have as much space between it and the RJ45 in case you've got any thick connectors or anything that go in there.
Right. So
that looks good.
And since we're not putting a nut on this, it's not this one doesn't screw through
Correct.
the panel. It can be right near the edge. Okay.
Correct.
All right. And then we need to.
Okay. Then the next thing we would have to put would be the headphone and mics on the other side. So it looks like we got 5 people in the chat room right now, but the chat room is awfully quiet. Your chat room make me nervous when you're this quiet. Is there any activity going on? What are y'all doing this fine evening, Saturday evening, besides watching us lay out a circuit board?
All right, so there's that. Now this is just the push-to-talk header.
And so, well, you could either use it as a header or you could populate it as an actual button. So, you would want the button to be accessible on the outside edge of the board. You can't do it there because you got to be able to slide the boards in and out. So it's either going to be the left or the right side.
Oh, I see what you're saying. So I guess over here.
I don't know.
Well, because the easiest thing to do would be to put a hole already in that PC board end plate, rather than try to drill the metal plate to line up all 3 of those.
Yeah.
So
no, that's too far over the board. That will get in the way. So it needs to be on the line of the board or to the left of it.
Like that?
Yeah, that looks good. Scroll in or zoom in. Oh, shoot. We're still in 0.5 millimeter, aren't we, right now?
Yes.
Yeah, those are probably going to be an inch because those are old components that are inch base. So I would change back to inch and go to a 0.025 inch grid. Oh, before you do that, hold on. Don't change your grid yet. Go to the intersection of the center lines.
And?
Hover over the exact intersection. Okay. Hit S, enter. So what that did...
Locked them?
No. That puts a point that will always be on the grid. That sets your grid, I think they call it a grid origin.
Okay.
Right? By default, your grid origin is in the upper left-hand corner of your screen. And so when you start changing your grid increments, whether your grid is a 0.5 millimeter or a 1 millimeter or a 0.25 millimeter, that's fine because those are all partials of each other. But if you go between millimeter and inches and your origin is up off in the upper left-hand corner of the sheet, not the board, but the sheet, right now that you won't be able to sync to that center line anymore because, that center line was so many millimeters over from the origin, but now we're so many 0.025 inches from the origin, right? So now, since we anchor that point on the page will always be on the grid. And then
no matter what the grid is.
Correct. And so the grid is out in the whatever the grid increments are from the center of our board.
Okay.
So now you can switch over to inches and it won't completely screw things up. So changing the units on the side between inches, mils, and millimeters, all that does is change what numbers are being shown. It doesn't actually change the grid at all. You changing the grid here is what changes where things actually snap to.
Okay.
Yeah.
0.025, is that what we were at?
That's typically what I use, yeah.
Okay.
0.025. Now try moving the 3.5 millimeter sockets again, and it will now snap to that grid. So you see, you're still grabbing it from a pad. Is there a way? Drop that. Hover over kind of like the front edge. Yeah, the board edge. Now hit M. Just drop it. It snaps you back to the pad, doesn't it? Hover over the J6 and see. Okay.
Now I'm on the J6 now.
Yeah. You're not actually on the J6. You're on the origin of the component.
Okay.
When I design these components, I like to make the origin at the board edge so that it will snap to the edge of the board.
Okay.
Like where the origin is now, it's in the middle of the component. And for that to be perfectly lined up with the edge of the board, you would need your grid to be whatever, some multiple of whatever the distance is between the center of the J6, the origin of the component, and the line of where where the front panel is. As it is, where you have it right now is fine because that'll be back from the panel a little bit, and it'll just give it a little bit of extra slop. But I like to have them right at the front panel. So, yeah.
Okay. Now we're going to move. Let's see. This. Where is it? That's connected. So that looks like up here would be a good spot for that.
So remember, that is between the amplifier and the RJ45.
Oh, so it needs to be
over
here.
I would actually recommend that we grab that entire amplifier circuit and move it away from the RJ45 a little bit. So you just select the whole thing. I would go up to the upper left-hand corner and drag down. Include C1. Yeah. And then hit M and drag it over there. Yeah, that's probably good. You probably want put that between R2 and J1. So down below. No. Yeah, right in there. And then you may need to rotate it so that the rat's nest isn't obscene. I don't know. I can't see it from here. Yeah, no, go one more. I think that's the right orientation because
that's
it looks
more better.
Yeah, it looks like the upper left-hand corner is going up to the yeah.
All right, and then we've got this test point. Is
that looks like it's between C1, or actually, you know what? I would move it above C1. Yeah.
Oh, it comes off of that pin. So
yeah.
Cool. All right, and then this one.
I think you can move that above C2 because it'll come off of that pin as well.
Yep.
Yeah, don't put it over the via. You'll lose the via, but yeah, right there I think is good.
All right, and then this.
So the PTT, yeah, right next to that PTT socket because they're going to be connecting to the same things.
And yeah, because my switch will be up here, so that'll be easy to just run jumpers down to there.
Hey, Kyle. AA0's AA0Z is in there.
Oh, really?
Hi,
Kyle.
He says, "Yo." Hey, Kyle. Good to have you on. Good to have somebody mentioning something in the chat. We're just playing a little KiCAD here. Nothing to see here. Except, lots of stuff to see.
The next thing is just to make this work with Node Red, just to make Kyle happy.
Yeah, sure, absolutely. Let's turn off the ground planes right now because it's confusing me. So over on the left-hand side, where your cursor just was, one down from there. Nope, down the blue kind of L-shaped thing. That one turns on the ground planes. Go to the one below it. That turns off the ground planes. There we go. It just makes it easier to see.
Okay, so the mic header. Okay, so let's just drag that temporarily out of the way. This one needs.
Okay. I would put the mic header. Now, remember that your connector is going to be coming over this board in this area, so you want those headers to be out of the way of your connector.
Right.
So I would put them closer over to the right side of the board. Especially the headphone connector, I would just put it right next to the RJ45.
Oh, like up here?
Yeah. And maybe even rotate it. Yeah, something like that. And the mic header is going into the input of the mic preamp circuit. So yeah, right up there.
All right. That looks better.
This is entirely analog, Kyle. I'd love to see how you would make this work in Node-RED.
All right.
Okay. So we have 2 ground planes currently defined. We got one that is the entire board, and then we've got the second one that's just that little section around the amplifier. And I can't remember how they were labeled before. Around the entire board we gave that one earth, didn't we?
Yep.
And then the one in the middle was ground, but that was when we had combined grounds. So let's
and then we have no mask on the edges where it slides into the the case.
Yeah. Okay. So let's take that that ground plane that's in the middle. And first off, we need to extend it so that it includes R1 and the mic header. So if you select the ground plane, you have to click on the edge of the ground plane itself. So select it, and then you should be able to drag either from the square corners or from the blue center or the circular center of the line. You've got a couple of extra points there that won't be a problem. Grab the blue. Yeah, that's fine. Grab that over, yeah, right about there. Go to the next square down that line. Right-click on, nope, square. That's a circle. Square. Click on that. Right-click on that, sorry. And then say remove corner. Yeah, there you go. What?
What did I just do here? Oh, cool.
Oh, bloody hell. Did we lose all that work?
When was the last time I hit save?
Oh. Wait. Yes, please. Okay. That wasn't that long ago.
Okay, so first off, we're going to hit save again.
Oh. Thank whatever deities listen to me for autosave.
We're going to turn this off. And now we're going to, so that's, this moved up into here, right?
Yeah. Yep. Somewhere around there. We can fine tune it later. The amp base, put that right above C1. Test point 2, put that right above C2. Maybe get rid of that via just to the left of it. There you go.
Okay, that's straight up.
Yep, that looks good.
Let's see, this one is what?
That looks like PTT header.
Push to talk, which goes over here.
Mm-hmm.
Mm-hmm. And this went
above
here,
R1. Right? Yeah, right next to R1 and
C1.
Right there. Yeah.
And headphone.
I would put it just to the left of the PTT button.
Down here.
Nope, above.
Where's
upper right corner? Upper right corner.
Oh, the button. Hi there.
Yep.
Yep. Right there.
There you go.
Okay, one more time.
Okay, save it.
Save. Yes.
Now let's select the that one. Zoom in that upper left corner there, and we'll see if it dies again on deleting those corners. Yeah, remove corner.
Oh.
Nope. Okay, remove the next one. So close. Well, we are finding the limits of what KiCAD can do. The joys of running the newest version.
Okay,
you know what? Forget it. Just drag those corners out.
Okay.
Just leave them there. That's fine. What? Okay, select that outline and hit Edit, E. Change that to mic ground.
Okay.
Yeah, click OK. Let's see if that makes this better. Okay, hold on.
It does not.
Let's read.
How about we delete it and draw a new one?
Sure. There were going to be some other changes elsewhere on the board anyway, so, or on that outline. Go ahead and delete it. Okay.
All right. So now we're going to draw a new one.
All right. If we're going to do that, then, okay. Next neat trick, lower right-hand corner of the entire screen. Yeah, selection filter. Click on the all items. Now click on vias. Okay. Select that entire area around the mic preamp.
Left drag or right drag?
Left to right drag. Although at this point I don't think... Okay, let me read this. What the hell's going on? Why is KiCAD...
Oh, sorry. Let's crash it again.
Yeah. I don't know why KiCAD's giving us such a hard time here. That's good, yeah. And that should select all the vias, hit delete. Sweet, okay. So that simplifies what we've got. Now select all items again. All right, Control S.
Get that.
Okay. I would grab all of that stuff and just kind of bring it down a little bit lower, center it on the board a little bit more. Especially since you're going to need 3 traces coming from the headphone header over to the headphone socket above this board, above this circuit, right?
Okay.
So
out there.
Yeah, that looks good.
Okay.
Okay.
So my left hand is getting spastic now.
With the Control S?
Yep.
Yep. While you guys are crashing KiCAD, I'm going to go eat some ice cream. That sounds good. And by good, I mean I'm jealous because that would just turn me into a gassy mess. And nobody likes it when I'm a gassy mess. All right. So let's lay down a new ground plane.
Okay. Is that this one?
The one right above it. Yeah, that one. Hold on. Before you click, since we have the silk screen selected right now, it's going to try and do a graphics area. We want it to be a copper area, so select the top, like front copper. Yeah, there we go. Now, oh yeah, it did unselect the tool, didn't it? Well, that's annoying. There we go. Not that high up. Go just above the test points. Because we're going to need space above this for the headphones. Nope, don't. Nope.
Oh,
just,
but it's click, draw, quick. Yep.
Yep. Click and create a corner, but it's actually going to bring up a dialog. Yeah. So select both front and back copper and make this mic ground. And zone priority level, make that 2. There we go. Okay. So, yeah. And then go down from there. So click that corner. Go down from there. We do not want to include all the pins. We only want to include the pins for the microphone. And that's going to be pin 3 is mic ground, and pin 6 is microphone.
Well, that's this one and this one.
Yeah. So go to kind of a space between and to the left of 6 and 8. Yeah, like right about there. Then go up to include 6. Unfortunately, the headphones, but we're gonna bring the headphones out of to the right from this, and probably on the bottom layer actually. So you know what, this will work out well. So go to the right of all of the pins there. Oh no! Do not go through ground. We want ground to tie to something else. So go down a little bit, kind of at an angle, and then and then go down to include 3. Go left one more. Yeah, there you go. And then go from there left all the way to kind of go right one more click. There. Then go at an angle up and to the left. No, to the left. Do a 45-degree angle. Stop between pins 2 and 4. Yeah, there, and then go to the left. And then down and around RV1. Yep. Yeah. You know what? Continue that. No, don't go all the way up there. Go up just to the bottom of the mic socket on the left of the board. Like right about there, and then continue to the left. Yeah. Include the mic socket. Go ahead and, yep.
Go beyond the edge of the board, or?
Yeah, go on beyond the edge of the board. And then right about there, and then go back over. What happened? Did you hit escape by accident?
Yep. Wait, will Control Z bring that back?
Nope, because you never actually created it.
I never completed it.
Dag nabbit.
Yeah. So I started up here.
Yep, that sounds about right.
All right, and then I go over here. And I go down in here.
You want to include pin 6 and pin 3 are the 2 pins that we're trying to get into this zone.
Okay, so I went over to about here.
Yeah. Yeah, and actually just go straight down between the pins. And then, yep, from there, then go out right, include mic ground, down, yeah, from there, down, then straight over. Yep. Yeah, we'll make that less ugly later. We can drag corners around.
Okay.
Nope, do not include the headphones. Only include the mic. Yep, all the way over to the mic header now. Okay, that's fine. That works. Save.
Yep.
Okay.
All right.
Now hit B.
To fill in.
And then turn on the yeah, that. Okay. Grab those vias that are in that plane and delete them. Getting some lag on there, and that's worrying me. Oh, shit. It never actually connected to pin 6 or pin 3. Oh, fuck. Okay. Okay, let's do this. Go to your trace tool, or your, trace. So the one right below the chip. Nope, over on the right. We're going to draw traces on the board. That one, yeah. Hover over 3, click, and drag straight to the left. Well, yeah, oh yeah, you got plenty of keep out room for that.
So there?
Sure. Okay, now hit B again. Yeah, okay, that didn't actually change anything. That's fine. But at least it connects it now. Yeah, that's super ugly. Let's try one other thing. Select your zone, the inner zone again, and hit E. Change your clearance to 0.015. And hit B again. So close. So do you see what I'm looking at? Like between 4 and 2, it's not connecting. Oh. But if you drag that horizontal line from the square that's between 4 and 2 and the square that's over to the left, if you drag that horizontal line down, it should connect.
So here?
Yeah, drag that down.
Control S. Now drag.
Now drag.
Hit escape. Now click. Now drag. It's not dragging.
Why is it not dragging? Oh, because you hadn't actually gone to the next grid.
To the grid point.
Yeah, you hadn't hit the threshold for the grid. So drag that down. Yeah, like all the way down. Just go straight across, straight through pin 2. And then do the same thing with the corner up above it to the left. Yeah, drag that down. There you go. Now hit B. There we go. That at least connects it. All right, delete that trace. That trace is just getting in the way. It's going to cause problems. Okay, look at the line to the right of 6 and 4. I want to connect that in as well. So do that same thing where you select the outline. Now grab that circle. Don't grab the corners. Grab that circle and drag it one to the right. That drags the whole line with it. Now hit B again. There you go. Okay. Okay. Save it, exit the program, and open it back up again. All that latency that you're getting right now is scaring the crap out of me. That means that it is chewing on something.
Let's close some stuff. Let's not close Zoom.
Beep. Pew, 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 pew. Whoop, whoop.
Okay, so
at our peak, we had 8 viewers tonight.
Awesome. Okay.
We're like real YouTubers now.
Oh, all right, so yeah, that should be enough stuff. So let's try KiCAD again.
Hopefully it's a little less draggy now.
Okay.
All right. Let's start attaching some of those rat's nests. I would start with the microphone is definitely going to be the most complex. So let's finish that out or complete that, I should say.
Yeah, that connects to nothing.
That is not good. There's a rat's nest there. Why is it not? Oh, you were on the ring. It's the tip.
Yep.
Okay, back up. Get closer to the tip. Don't connect it there. Yeah. Go back over there. You're zooming around too much.
Yeah.
Go up, and you can click as you are dragging it, and it will kind of lock in what's to the what you've already drawn. So go to the right and get farther away from the edge. Move down from where you are right now. Now click. Now keep dragging. And then, no, back up. Nope, yeah. Right there. Click again. Now continue on. There you go.
Okay.
Hit B. And, okay, that gives us plenty of ground plane above it, of mic ground plane above it, so that's good.
This...
Oh, nope. You don't need to connect that because remember that's our plane.
Ground.
Yeah,
but it's got a rat's nest.
So what? Okay, zoom into that. See there's that via is still there. There's a via on top of the no below down on the.
Oh, there it is.
Yep, that one.
Not anymore.
Now hit B again, and notice how it kind of completed that thermal.
Yeah.
Yeah. All right, so we're good there.
Yeah, because the only other mic connection is ground. All
yep.
right.
Yep.
So now let's go here.
Let's keep doing the mic. I want to finish out the mic circuit.
Oh, we get the mic header next.
Yeah, and just all of this because, and then from the mic header into C1, I think. Yeah.
I got out of the tool.
Yep, it happens. Cha-ching.
And that's just ground. Nope.
Yep.
That comes down here.
No, it's ground. It's already connected.
Oh, because this is already ground.
Yep. So there's nothing there.
Okay.
Turn off the ground plane so that we can see the rat's nest better. That didn't help me see the rat's nest any.
All right, so we can draw from here.
Oh, excuse me.
Gesundheit.
Comes out loose.
Okay, that goes there. That goes there.
Yep.
This goes.
Yep.
Down here.
Yep.
Why does that also show going over to here?
Because that is the goes outa.
So is that coming out of this side of the capacitor, though?
Yes.
Okay, so then I have to make that go up. And
I would have it go up and around. Yes, correct. Because you're going to need to have a line coming out of pin 2 of the capacitor going down to RV1. Yeah. I wouldn't do it that high, but that's fine.
So like
no, not even that high. Just barely above pin 2. Yeah, that's fine. And yeah, there, and then down. Hover over that corner and hit G for drag, and then move it one to the left. Oh.
Close enough.
That other point is not at a 45. Okay, yeah, that's fine.
All right.
But
so
you can drag corners around of
Okay.
the schema of the
and this one goes down to here.
Yep.
Let's
Oh shoot. That's supposed to be mic ground, not ground. Go back to your schematic. Yes. Okay, yeah, that does look correct. All right, so you see how the ground at the bottom of the pot? Replace that with a mic ground.
Oh.
Stick it on that corner. Perfect. And click save. And then update that from the schematic. Yep, exactly. You got it. And reconnected RV1 pin 2 and 3 from ground to mic ground. Correct. That's it. Because all we did was change the net list. We don't have to worry about anything else with the symbols. Now those 2 pins are mic ground. If we hit B, that rat's nest should go away. Boop. Okay.
Awesome.
Okay, look at
and they both say mic ground.
Exactly. Look at R3. And look at pin 2 on R3. You got that little hair of a trace there. Get rid of that. There you go. Okay. All right.
That's also mic ground.
Yeah.
So now there's a lot of ugly lines up here that are just going everywhere.
Yep. Those are our headphones and our PTT and stuff like that.
Yeah.
So, first thing we're going to want to do, let's go ahead and do the headphone first. So that's going to be pins 4, 5, and 8. So 4 and 5 should come out on the RJ45. 4 and 5 should come out to the right. And we're going to, nope. Don't do red. Let's put these on the bottom layer.
Okay.
So do B copper. Yep. And grab 5. Yeah, I was afraid of that. Nope, don't go down the center. Whoa. Damn it. Yeah, I was afraid of that. Oh, but I think we could do it coming in the other side. Okay, that's fine. Yeah, go into pin 3. Get rid of that via just to the left of pin 3. And then go from pin 8 up the left-hand side into pin 2 of the header. No, go straight north out of that pad because we want to avoid the ground plane, the mic ground plane. Yeah, and then from there go over up and to the left. Yeah, like that. I generally try to avoid right angles. I don't know why. I don't think electrons give a crap about making left angles. I think they do at RF, but not at audio levels. But it's just kind of a cleanliness thing. I generally try to avoid right angles. But
except if I do that, this gets weird.
So just click more. You know, like go partially where you want it to be, like right there. Click. Yep. Yep, exactly.
Okay.
All right. And then from here I can
redo this one.
Sure. Okay, let me show you a trick. Okay, so you've got that horizontal wire selected. Go to the left 2 clicks. I think that was 3. Right there. Right click and do create corner. Or break track. I'm sorry, break track. It's a third one down. Now hover over the corner to the right and hit G for drag. Yeah, that one. And then drag it down. Oh, really? Come on, KiCAD. Yeah. Drag that corner, the one that you're over right now. Drag it down. Oh. It thinks you're too close to ground. Ah, shit. Okay. Hover over the big vertical bar, the big vertical trace.
Mm-hmm.
And hit D, I think. Oh. Did you hit D?
I did. And it let me drag it, and then I clicked out.
But it drags not what I was expecting it to. Kind of hover over the center of that vertical trace, hit D, and then drag it to the right 1 click. There you go. So G will drag corners, and D will drag, actually, I think it will do a corner as well, but it will drag an entire line on 45s. And so you'll notice that the 2 45s that went into that line, all it did was continue that 45 line as it dragged it around.
Okay, we don't need this via here under the 45, right?
Correct. Yeah, we're going to just redo all the vias, so delete that.
Okay.
Now, we got the PTT. So go back to the top layer. And we're going to grab pin 2, which is PTT, and pin 7, which is ground. Yeah, and then I would stay immediately to the left of the big blue circles. Right there, and then just go straight in. Yep. And then pin 7 into the other side. It's not exactly on a grid because they're not 0.1 centers.
Okay.
All right. Now, drag your board up so that we can see closer to the bottom of the board, because you got more PTTs down there. We're going to have to connect those same pins down here. You don't want to do that because that's going to cut off the mic ground. All right, so let's show you how to do a via. That's okay. Go to the right of those blue lines.
Stay in this.
Stay where you are. Just go to the right of the blue lines. Nope. No. Between the blue line and the red line.
Oh, the blue lines. I was looking blue circles.
Got it. So right, we might have enough space in there. Zoom in some. And then type V. Hit enter. And then continue dragging. You should now be on the blue line.
Okay.
And then if you want to do a via again, another V, enter. Now you're back up on the top. And so now you can go down to the ground. Yeah, just keep it parallel with the other one.
Well, except I can't go through here.
No, you can squeeze between where the red line is and the blue circle. Yeah, you can do that. And then go around to the ground. Yep. Go to the ground over on the right. Just connect in with that. And then from there, I would go underneath the PTT, the tip connector right there, under, from the sleeve, and then go down below it, underneath, up to the ground on the pin header. You may need to remove those vias.
Okay, so go from here.
Nope. Sleeve over on the far right.
Oh, okay.
Yep. And then just go.
And I got to get to here.
But go down. Don't go above it. Yeah. And then up to there. Yeah. Because that way that leaves the spot open for the PTT.
Which is right here.
Yep. And from there you can go up. And then connect it to J3. Yeah. I would go into, yes, to the left side of the pad. There we go.
All right.
Okay.
Oh, Control S.
Control S. Oh, my gosh, yes. All right. I think the only thing we have left to do is to connect the headphone 3.5 millimeter socket on the left to the headphone pin header on the right. And I would do that on the top layer, but make sure you avoid the microphone ground plane. Nope, that's the switch socket. Yeah. Yep. The switch pin. And then go up. You want to avoid that ground plane.
Yeah, I see it now.
Remember, you're going to have to leave space for one more trace below that trace. What you're on right now is your middle trace of the 3 that are going to go across. We can also drag that that ground plane down. It doesn't need to be that high. Grab the circle and just drag that down a bit. Yeah. Yeah, that looks good. Okay, cool. No, take that up. Yeah. Then we'll go down with that. Yeah. Now make it parallel to the others. Bring it up close to the other 3, the other 2. Yeah, like that. And then bring it down to pin 3.
Do I have one more coming, or is that it?
Nope, that's it. Just the 3.
Okay.
Left, right, and ground. Cha-ching. That's a board, my friend. Why? Oh, hit B. Because you, yep, there you go. Because you redid the, you dragged that line of that center ground plane, so it had to be redrawn. Oh, look at that. All right, so we've got areas that it cannot make contiguous with the copper pour on the top layer. So one way to handle that is to move your traces so that you can get there, but there's like the big area between the RJ45 and the 3.5 millimeter PTT below it that there's just no way to open that up to make it get connected. So what you do is you drop a via, because it does have ground on the bottom, and so all it needs is for, not ground, earth, excuse me. It just needs an earth via there. So go to the via tool, the yellow circle, and then select the bottom, yeah, that tool, and then select the bottom copper layer, and that tells it what nets to put that via on. So click right there. You've just dropped one via. Now hit B again, and you'll see that area get filled in. Yep. Do that for the other areas that are kind of empty.
Like in here?
Yep, do one there. There you go. And that covered that whole area. And then I would do one. Oh, you got them going the other direction. Like up by the headphone header, the bottom layer couldn't get filled in. So I would drop some in those areas if you can as well. So like one right there. Yep. And then one in there. Bloop. And then do one kind of underneath the RJ45. Yeah, right in that space there.
Does that need one over there?
Yeah. Go ahead and do one there. And then actually, just to the right of pin 3 on the RJ45 as well. There you go. Yeah. Now, I would also drop some vias on the mic ground. Oh, yep, up there would be good.
I don't know why I put 2. And put in here.
Sure.
Well, okay, let's wait and see when we drop the graphic in, and I'll try to make vias line up with the stars.
Oh, yeah. Yeah. Graphics, I forgot about that. Yeah. So, KiCAD 7 has different ways of doing that than KiCAD 6. So, I don't know what the how to do this. So, we're going to be learning this together. So, you've got the image icon there that I don't think KiCAD 6 has. Let me see whether I'm lying. Yeah, there is no image tool.
Oh, I don't want this on the copper layer. I want this on front silk screen. Right?
Could do it on the copper layer. You can do it in lots of different layers. I don't know.
But I mean, if I put it on the copper layer, that's trying to tell it to draw
traces. Yeah.
Yeah.
So put it on the silk screen. But there are lots of creative things you can do with, silk screen, solder mask on top of copper, solder mask on top of fiberglass, copper with no solder mask. Like, there are all kinds of weird things you can do. That did not get turned into a... How is that going to work? Go up to View in the very top bar, the Mac View. Yeah. And 3D Viewer. So, yeah, it's not showing up at all. Huh. Go ahead and close that.
That's somewhat problematic.
Yeah, I don't know how that's supposed to work.
It says it wants a bitmap.
Bring up the tool again.
See, and if I hit escape, then it's just... I don't know. So now I can do a PNG.
This is just a file chooser.
Yeah, the only things it's accepting is bitmap or be a PNG. Okay, so if I want to delete this for right now, and then bring this back up.
Which was the one you did first? Was it a BMP?
Yeah, let's try ping.
Okay. That's big. Okay, hit E. Image. Hit gray. What does that do?
Like nothing.
Go back up to the 3D viewer. Huh. I don't know. The way to do this in KiCAD 6, go back to the not the schematic editor, not the board editor, but the third window, the project window for KiCAD. Image converter tool. Open up the image converter tool. So load source image over on the right. Okay. So drag that black and white threshold. Well, this is just a strict black and white image, so it's not going to make much of a difference. But if you've got a grayscale there, what that does is that changes where the definition between black and white works.
Right.
It can only do it's there or it's not. You might be able to do dithering or
Okay, I think this is what we need. Some YouTube stuff as KiCAD symbol.
Yep.
So
you don't want to know symbol. We'll put it on the schematic. You want a footprint.
Oh. Okay.
Yep. And then
front
you can
silk screen.
Yes.
Or front solder mask. Let's do front silk screen.
Yeah, silk screen.
Export to file.
Yeah. So what you're doing now is you're creating a library. Remember when we were selecting footprints, there was like the left-hand column with all the libraries and the right-hand column with the parts and stuff like that. You are creating a new library right now. So yeah. Yep, exactly. No shape in black and white image to convert. No outline created. Okay. Bring the threshold back closer to like 50%. Loads. Yeah. Okay, hold on. No shape in black and white image to convert. No outline created. Okay, click there. I think there's more that we have to do to actually convert the image. Undo negative.
Try to export again.
Yeah, try that. There we go.
No error.
No error this time. So now what we're going to do is we are going to click the chip in the upper right corner. Yeah, that one. And there should be a new thing here called Cygnus. Okay, hit cancel. File properties. I think you may have to add the new library that you just created. Sorry, preferences. No, it's parallel to file. It's over to the right.
Oh.
Manage footprint libraries. And I think what we need to do is add a library here. Call it Cygnus. This is basically just going to be your library that you use for any time you create a new thing. Did you notice where it created that file, the Cygnus library?
Yeah, it's still in the source folder.
Okay. So that's fine. Go ahead and give it a name. Just call it Cygnus. And then in the column to the right, the directory, the library path, you need to tell it where to find it. It's right there, KiCAD mod. Did it not?
It's not. Okay, so let's just say open. And then...
Shoot. No. All right. I don't think that'll work, but let's try it. Click OK. And try dropping a new library component. Or a footprint. Huh. There it is. Yeah, that's unfortunate. I don't think you can scale things on the board. So, okay. I was wondering whether this was going to happen. So go back to the footprint editor, or the image importer. Oh, we've already got it open right there. So there, and yeah. Change that to whatever size you want it to be when it's done.
Okay, so the board is 85 millimeters long, so
maybe 20?
10, 20.
So yeah, Cygnus underscore 20 millimeter, something like that. Or yeah, the logo name underscore 20 millimeter, right? You know, yeah. just make it clear that it's, you know, the smaller version of it.
Oh wait, it was Cygnus open circle, 20 millimeters. Oh, I already did that.
Yep.
Okay. So now I got to go back to the footprint editor.
Or the board.
And add it, right?
Yep. Add the footprint.
Which was...
the chip up there in the upper right?
This one here?
Nope. No. I'm sorry. Where was your cursor? Not there. Not there. No. Yes, that. No. Yes. Wait, nope. What?
That's the picker. Where was the footprint editor?
Why do we need the footprint editor?
Do we need to add that new one in?
Nope, because you added the directory.
It will see that it's there.
It should, because you added the directory, so it should see all the mod files that get loaded into there.
Got it.
So,
yeah, look.
Yay, look at that.
Except I have it labeled 20 meters, so it's really big.
That looks pretty good.
Yeah, put that.
And that G star we'll be able to get rid of. So select just the G star. There you go. Hit edit. Oh, that works. Yeah, that works too. Okay. Hey, look, you've got graphics on your board. Maybe add some text for a copyright, or
yeah,
you know, whoever it is that did it, put your call sign on there, whatever you want to do.
That'd be the T.
Yep. Oh my gosh. I'm not even Central Time and I'm getting tired. There you go. Dude.
We have a board.
We have a board. Go over to the 3D viewer. Yeah, view.
Under view.
View, yep. Dude, look at that. Zoom in, make that bigger.
Looks like a thing.
That's a thing. You can flip it around and look at the bottom side.
Although, why does it not have... So it's got the push button.
Yeah, so not every model, not every footprint has a 3D model.
Oh, so there's no 3D model for the RJ45.
Correct. Or for the 3.5 millimeters either.
Yeah, okay.
So the only thing that I see that's missing are labels on the board so that you remember what each of those sockets. Yeah.
Okay. If I leave this open, will this update in real time, or do I need to close it?
No.
Okay.
It updates in real time. Well, it updates as soon as you give it focus.
Okay. So first off, save.
Save.
All right. Now, text.
BTT.
Headphones.
Yep. Mick.
Yep.
What time we started? Man, yep, we're going on 3 hours, aren't we? 2.5 at this point.
Yeah, it's about 11 o'clock here.
Yeah. Yep. I would also label the individual pins on the pin headers as, mic ground, PTT ground, left, right, and headphone ground.
Okay, so this is the headphone header.
Yep.
So
I happen to remember that 1 is left, 2 is right, and 3 is ground.
Good. Okay, so headphone right.
Center.
1 is
it's in 2.
Center.
Really quickly, zoom in on J4. You can also see the node names on each of the pins, if that helps you. That typically only helps you on nodes that have been named. Like if you zoom in on one of the capacitors or something, you're going to see like net C1 dash, pad 2, which is less useful. But typically, you're only trying to label things that where the nodes have been labeled already for you. So. Excuse me. My goodness. So we still got 5 people watching right now. Chat room, You're being awfully quiet. Kyle did his part to spice up the chat room here, but we got there's more of you. Come on, say hi. Who's out there? Who's watching?
Actually, these are both PTT. Because it's just a switch.
Excuse me. That is technically, but if you ever need to do anything with it, or if you want to tie it to something else, knowing which one is which is important.
Okay.
Let me show you something. Okay. This is not critical for what you're doing right now, but I'm going to show you anyway. Hit escape, get out of the text tool.
Yep.
Hover over ground and hit M. Notice how, it didn't actually move you. There you go. How it moved you over to the left corner.
Mm-hmm.
Okay. Now try and drag it. You're dragging it by the left side of the text. I wonder if this is changed in 7. Hit escape. Hover over the D, the lower right-hand corner, and hit M. No, it still moves you to the left. Okay. Hit E. So, okay. They've changed it to the graphical buttons. Look at you. So it's got the standard, left, center, or right justified.
Okay, I just hit right justified.
Okay, now hit move.
And
it grabs you to the right corner. Now, the advantage to this is if you do that for both of those, now they will snap to the same grid, and they will be justified on the right-hand side. Right? And so now the right-hand side of the text lines up.
Oh, look at that.
Yeah. So, not critical, but if you are trying to make your text all snazzy and consistent. No, that one is headphone ground.
Except that it's ground in this context.
It is a different signal in OHIS.
Okay. All right. So HV ground. Trying to shorten it up a little and make that right.
No, use GND. You use GND everywhere else.
Fine.
Be consistent.
All right. And it's
You're just lucky I'm not being pedantic enough to say lowercase nd like you use everywhere else.
I'm fixing that.
You're going to make them capital GNDs everywhere?
I'm trying. All right, so that's right justified.
Okay.
And then move.
There you go. And that same text works, or that same trick works on other text as well, I think, if I remember correctly.
So this one I got to fix.
If you want to. There's a cat trying to bust through the door into my office.
I know that feeling. My guy desperately wants to hang out down here, but I've learned that right now I can't trust him to not just pee on stuff.
Yeah. Dude. It's a board.
Okay, and this one's going to be left justified, which it is.
Yep.
And then move. Let's drag this over here. And this one. Move, drag over here. That's pretty much lined up. Now, were we going to try to drop some vias in here?
If you want to. I have no idea whether they'll line up with your artwork or not.
Yeah, front compers. So let's see how that works.
So what you would do here at this point is either turn off the grid entirely.
Well, it's not, because they're bigger than the...
Yeah.
Okay, so we're just going to draw some vias in here anyway, because there's a lot of empty space, right?
Yeah, so specifically, the little tiny strip of mic ground between the mic signal and the upper edge of there, you want to drop some vias in there and just kind of around the mic signal, that long mic path, yeah. Yep. Just like Emerald Lagasse. Bam! More vias.
Oops. Don't want that one.
All right. Some other recommendations for places to put vias. That little island just to the north of Q1 of your transistor and just to the east of the transistor.
Or the transistor.
Yeah. So anytime you have like a flap of copper, right? You don't want that flap to be flapping in the wind. Like electrically speaking, that's actually what it can do. We're only dealing with audio here, so it's not going to be that big of a deal. But when you're dealing in RF, that's a non-trivial wavelength of some of the harmonics of the shit that we're talking about. So you want to make sure that is not left to flap in the wind. You want it to be tied to a good solid ground.
Okay, this is not text that's going to show up on the silk screen, is it?
The TP1 will. Okay.
This part won't.
The amp base and goes out does not, correct.
Okay.
So if over in the right-hand corner, or right-hand side where you've got layers, change that to objects. Up at the very top.
Oh.
And I think you want to turn off values, because values do not end up on the board. So if you just turn off the visibility, there you go. So now, but there's also, no, references do get printed. Scroll down. What's the one right below references? Footprint text. Turn off footprint text. There you go. Now, no, turn on footprint text again. Oh, that turns all of them off. Turn off values again.
And right now, my silkscreen stuff is like buried underneath.
That's because of the current layer that you have selected. Go back to layers.
Oh, okay.
That's because you have the copper layer selected. If you select the silkscreen, it'll put it on top.
Okay.
Yeah. Now, do you see how there's like the little R1 in the middle of the rectangle next to the big R1 that's on the silkscreen?
Yes.
That little R1 will not get printed.
Got it.
I don't remember. I think it's on a layer. Like FFab. It's not user drawings, I don't think. Try turning off user drawings. Let's see if it's that one. Nope, that's not it. Turn that back on because we want our crosshairs. Try... it's not edge cuts. Try FFab. Try turning off FFab. It's down near the bottom. There you go. Turn that back on. And off. Yeah. Okay. I think that's the layer that is used for fabrication.
I can see like R1, R2, and that disappears when we turn that off.
Yeah. So that right there, I think, is what you're looking at is what's going to get printed.
Cool. Alrighty.
All right. I am going to be pedantic about one thing.
Right ahead.
The two traces that are right next to each other underneath the RJ45 on the right-hand side, kind of between the two big blue circles.
Right here?
Yeah. I don't like the fact that those two traces are so close to each other and they squeeze off the ground plane. So I would, the earth to the upper left of where your cursor is, move that directly north by one spot. Then hover over the center of the 45 degree of that PTT and hit D, and then move it up and to the left by one.
Left?
Yeah, like that. Up. Yeah, do that. Hit B. Okay. So that recombines those two.
Perfect.
There we go. Okay.
Do we need a VA in here, or is there enough?
Yes, definitely do a VIA at the other end of that little tiny trace.
So like in here.
Sure. But also just to the... Down. Yes, right there. Yeah.
Okay.
And then down closer to J3, anywhere you've got those little flaps of copper, right?
Oh, like down in here.
Yeah. If anything, I would take that 45 and drag it to the right, to the point where you can fit a via between them.
That's G?
D in this case. Yeah. I would go even more. There you go. That's probably good. And then B.
B.
Fill your thing. And then drag that earth via down to the corner. Sorry, M. Move it. I'm trying to use the right terms. There we go.
Okay.
Drop another via between TN and RN. in the 3.5 millimeter.
Oh. So
in the down below.
Oh, I'm sorry. It's
tired
late. Brain.
It's late. Yep.
So down in here?
Yeah. And then another one between RN and T. Yep. There you go. And then probably grab some just to the north of S. Yeah. And maybe kind of down in that corner, lower right-hand corner of the board. Yeah.
Not there, though. That spare space you didn't want to be as...
It'll be fine.
Okay.
Because I don't think you have enough space to go farther up. And then those ones that you put in the middle of the 3.5 millimeter, put them on the other two 3.5 millimeters as well. Yeah. Between T and R, because that's where the flap is. Right up there. And then another one underneath the H for headphones, or kind of in that upper right-hand corner. Yeah, right there. Perfect. Yep. In general, anywhere you've got a corner or a finger of copper, you know, if you can anchor it down to the copper beneath it, that would be good.
All right.
Fucking A, Bubba.
Command S.
Command S. You, my friend, have a board. So, a needle pulling thread. Woohoo! All hail the halibut. Okay, that got awkward. Go to tools.
And?
I'm looking. Hold on.
All right.
External plugins.
Add teardrops. That's when you get them back and you realize they don't work.
Oh, so sad.
All right, external plugins.
Yeah. Isn't there a plugin manager? Maybe preferences? Try the preferences window?
No.
Go to file, maybe? Oh, you know what? It's not here. It's on the project board. So, yeah, save your file and then minimize this window or just move it out of the way, whichever. And I think it's on this window. Go to preferences. Oh, no, plugins and content manager down at the bottom. Okay. KiCAD is not the one I want. Do a filter for JLC PCB or just JLC. Fabrication toolkit. JLC PCB fabrication toolkit. That is not the one that I'm using, but that might work as well. Go to libraries. Nope, not that. No, plugins. That's it. Is that the one I'm using? KiCAD JLC PCB tools. So no, I'm using a different one, but that's okay. Go ahead and, yeah, you've got that installed?
Mm-hmm.
Let's take a look at that. Okay, close. Then go back to the thing. And then I think tools, I think we did see a reload external plugins, right? Refresh plugins. There you go.
It's there.
Oh, there we go. Fabrication toolkit. Let's do it. This is a different plugin than what I'm used to, so oh. Whoa.
Wait, what
did it already do it?
It just opens, yeah, I guess. Because there's Gerber.zip.
Gerber.zip.
Well, that was zippy.
That was easy. All right, bring up a browser.
This is it. It opens up a Finder window.
No, like a web browser.
Oh, okay. Let's see, what do I still have open? Firefox is open. Okay.
Control-T, jlcpcb.com. InstaQuote, or click on the Add Gerber, whichever. It all gets you to the same place. And find that Gerbers.zip. Okay, let's let it do its thing. Oh, hey, we got more stuff. Jesse, just soaking up the KiCAD, looking good. Also, Eastern time here, so getting pretty sleepy. Yeah, heck, I don't even have the Eastern time zone to blame it on. I'm getting sleepy. Hot diggity, look at that. It loaded up your boards right away.
Wow.
And so you can iterate on this process, and you're going to look at the board and go, oh, I don't like this. Let me go change this, that, and the other thing. And you go in and you make some changes, and it'll export the files again. You re-upload them until you're happy with it, and then you can order it straight from here. I'll tell you right now, those $2 boards are going to cost you $20 in shipping.
Yeah.
So if you've got any other ideas for other boards that you might want to do, it's still $20 in shipping.
Yeah, this is where, and since it's now 11 o'clock.
Yeah, I think we're done for tonight.
Yeah, we still need to do the end plates.
Yes.
But that shouldn't take long.
Yeah.
Because that's just measuring and
famous last words. Things are never supposed to take long.
But there's no actual circuitry on them.
Correct. So that's actually, before we go, let's do one more thing. Open up a new tab as well, another new tab, and go to oshpark.com.
Spell that.
OSHPARK.com. And get started. And so browse for files. Oh, hey, can you just drag and drop? Yeah, you can. No, not Gerber.zip. Oh, yeah, maybe you can. Never mind.
Zip Gerber files.
Yep, but you can also upload the KiCAD.pcb file as well.
Oh, okay.
And it will do its own exporting. But if it takes zipped Gerbers, you can do that too. So if you wanted it in purple, you could.
$3 will cost $30.
And that includes shipping.
That includes shipping.
Yeah, I think it includes shipping.
I would hope.
Yeah.
All right.
Yeah. So, you have the different options here. Lane is the guy who runs OshPark. He is fantastic. His support is phenomenal. Like you call them or text them, and you get a person on the line right away, and they have bent over backwards to help me fix problems in the past. So I will speak forever highly about OshPark's support, and they fab everything in the US. And, even if you get a little tiny 1-inch squared board, they'll still ship it to you for the same price. It's just wonderful service.
Okay.
The problem for me, the reason I don't do it is because they also don't do assembly. They don't also do assembly, and I've gotten to the point where I need assembly done on most of my boards. So I send it out to JLC for that. So,
all right,
man.
So let me save this one more time and let's close.
I am really curious why that kept crashing on us in the middle there.
Yeah.
Rock and roll. let's find some other time to do the panels, unless you think you can do it yourself, which I think you can if you want to do it yourself.
Well, that one's going to be trickier because of that's actually doing dimensional measurements from the board on up.
Yep.
And stuff. So maybe the first one of those, I could use help, then I would understand how to do the process.
Okay. Do you have 2 or 3 minutes that I can show you one critical tool right now?
Yeah.
That we don't have to reopen anything or anything like that. All right. So there's another tool on PCB schematic. Go to the T, and it's 2 down from the text tool.
This one?
Yep, that one right there. Now make sure you're on the silk screen, or I'm sorry, on user drawings, because you don't actually want these to show up on text. So make sure you're on the user drawings layer, then select the measurement tool.
Yep.
Okay. Now zoom in on the center line, kind of over on the right-hand side. Yeah, exactly where you are there. Go over to the left to the board edge. Okay. Click there, and see how it's got that circle?
Mm-hmm.
What that means is that it is snapped to an intersection of lines,
not the grid line and the board edge.
Yeah, not the grid, but the center line of or the intersection of those 2 lines. Now, go down to there. Now, unfortunately, you're going to have to find the exact center of that. It was because you grabbed that component by its own origin, that its own origin should be in the center of the center line of the connector. Yeah, like I think if you click right there, that should work. So click right. Nope. No. There.
Right there.
Yeah, click there and then drag to the right. There you go. Now zoom back out. Yeah, that did not look perfectly centered. But that
looks like down a little.
That looks down a little bit. So you may have to move the 3.5 millimeter socket to get it into so that it is centered on on a grid. And I don't. You may have placed it when you were still in 0.5 millimeter mode, which will involve moving those traces around a little bit. But it's not the end of the world. The point of this lesson is the measurement tool.
Okay.
So the measurement tool you can use, and as long as you're on user drawings layer, then it doesn't show up anywhere. It's just for you and your user drawings. But you can use that to say, all right, now I know between the center line and the center of the 3.5 millimeter socket, which is going to be a circle that I have to put on the panel. Now I know that exact dimension, right? And you can do the same thing with the switch over on the right-hand side, or on the above the RJ45, and then on the other left-hand side of the board, you can do the same thing with the 3.5 millimeter sockets there.
Right.
And that way you can get exact dimensions relative to the board, and then you know where the board is going to be relative to the case, and so you can do all of the math to figure out exactly where on that panel you want everything to be.
Okay, and this is the actual footprint of, or the actual dimensions of, or at least the horizontal dimensions of the RJ45.
Correct.
Okay.
Yeah.
And then the thing to figure out how to determine is the height of those protrusions vertically off the board.
Yes. So. Yes. And it helps to have a component that you know a part number, even if you're buying the cheap eBay knockoff. If it's a knockoff of a specific part, they're going to make that knockoff fit in all the same holes, right?
Right.
I also highly recommend you invest in a good micrometer. I'm going to guess he's going to pull up a good micrometer.
A decent micrometer. I don't have like a Mitutoyo, but...
Yeah, okay. You and I are on the same price level here.
Yeah.
$5, $10, $15, not hundreds of dollars. But with this and the RJ45 sockets, you can say, oh, hey, look, those sockets are, how about I turn it on? Those sockets are
13.4 millimeters.
You're measuring tall?
Yep.
Okay, I was measuring wide. Yeah, exactly.
And wide is, 15.8. 15.9.
Yeah. I just round that up and call it 16. And the other one I would round up and call 13.
Yeah, because it's better to have a little bit of breathing room around the hole.
Especially since you the milling of holes in a PCB is not perfect. So I would give it at least 0.1 or 0.2 millimeters on either side. Yeah.
Okay.
So that's it, man.
Awesome.
You have got a board.
And Control S again.
Control S again.
All right. And then we'll figure out a little bit of time to finish the end plates, and I'll send all that off and get some back.
Very cool, man. I'm excited to see how this turns out.
Yep. And then I will also, while we're at it, measure the voltage on the pins for the radios in the car and see what that is.
Yeah, see whether those radios are outputting a 5-volt or a DC voltage, bias voltage.
Yeah.
Yeah.
All right.
The good news, if it is outputting a bias voltage, then that circuit that you've built right there is exactly what you need for that. So,
cool.
Cheers, mate. Have a great evening.
Later. Yep. Bye.
Bye. I'm going to end the stream and click the end stream button and click yes. Thank you, chat room, for hanging out with us.